You're going to learn about a directed line segment. So what a directed line segment is, and then how to partition it given a ratio. So let's go ahead and start. So what is a directed line segment? Well, a directed line segment is a line segment with an associated direction. So in this case, we have a line segment A, B, and if we want to give it direction, then one point has to be the starting point, and then the second point has to be the ending point. So in this case, let's make A the starting point, and so then this is going to be called the initial point, and then point B is going to be called our terminal point. Now, I'm having a little bit of trouble with the script here, but we can give point A the coordinates x, so it should be sub 1. But I can't do the sub, so I'm just going to go x1 and then y1. So those represent the x and the y coordinates. And then point B is going to be x, it should be sub 2. And then y sub 2. So those are the x and the y coordinates of point B. Now, if we make this line segment into a right triangle, like we already know how to do when we did Pythagoras, we have two components. So then this part is called the horizontal component, and then this part is called the vertical component. And so in order to get the horizontal component, we would simply do x sub 2, which is the x coordinate of point B, and then minus x sub 1, which is the x coordinate of point A. And the vertical component likewise would be y sub 2, which is the y component of point B, minus y sub 1, which is the y component of the y coordinate of point A. So let's go ahead and take a look at this first example here. The question is, find the horizontal and vertical components of the directed line segment PQ to the left. So this is the graph that goes with this example, and you can see the line segment PQ. Now, I can't draw this in on this PDF, but the first thing to do is to make this into a right triangle. So then on your piece of paper, you can go ahead and draw a line from P up to this point. So that would be the horizontal component. And then draw a line up to Q to make the right triangle, and that would be the vertical component. So then to find the horizontal component, you would basically count the number of squares. So it would be 1, 2, 3, 4, 5, 6. I actually should go back to here we go. So then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we would say the horizontal component, or we can just call that, well, I'll just write it in, horizontal component basically equals 9. And then you can also get that by doing x2 minus x1. So in this case, we know that x2, so let's just go ahead and put in the coordinates. So point P has coordinates, x coordinate is 1, and the y coordinate is 2. So that's 1, 2. And then point Q has the coordinates. So the x coordinate here is 10. and then the y coordinate, if you count up from the x-axis, is 6. So it will be 1, 2, 3, 4, 5, 6. So then another way to find the horizontal component is to do x2 minus x1. So x sub 2 minus x sub 1 equals 10 minus 1. So that's 10 minus 1, and then that equals 9. So you can get the horizontal component both ways, either just by counting off squares on the graph or by subtracting the x-coordinates from each other. So then, likewise, let's find the vertical component. And so if we look at the graph, it's going to be 1, 2, 3, 4 squares. So it's 4. And then we can also do y sub 2 minus y sub 1. So we know y sub 2 is 6 minus y sub 1, which is 2, and that gives us 4. So then pause the video for a minute and go ahead and do example 2, and then I'll give you a small piece of graph paper so that you can go ahead and plot that. So you can do it graphically, or you can also do it by subtracting the components from each other like this. All right, so let's talk about the next part, which is partitioning a segment. So to partition means either to divide or to separate. So we can partition a line segment into smaller segments and compare their lengths as a ratio. So then if you recall, a ratio is basically comparing two numbers to each other. So for example, 1 to 3 or 2 to 3. So that would be a ratio. So let me just go ahead and put that in right here. Example 1 to 3. So then it's like 1 parts to 3 parts. It's like 1 cup of sugar compared to 3 cups of sugar, or 2 to 3. So you're comparing 2 cups of sugar to 3 cups of sugar. So let's take a look at example 3. If line segment AB is partitioned into 5 congruent parts, give each ratio. So just as a reminder, we know that congruent means equal in measure. So then AB is divided into 5 equal or congruent parts. So it's 1, 2, 3, 4, 5. So it wants us to find the ratio of AP, which is this part, to PB, which is this part. So then AP is 1, 2, 3. So that's going to be 3, 2. And then PB is 2. So it's 1, 2. So on your own, go ahead and find AP to AB. So AP is part of it. AB is the whole thing. And so this is an example of a part of it compared to the whole length of it. And then after you do that, go ahead and complete 4 and 5, and then come back and finish this video. All right, so then the last part is basically, if we're given a line segment and we're given a point on it, then, and we're given the ratio, then we have to find the coordinates of that point. So let's take a look at example 6 together. All right. So the question is, given directed line segment AB below, so this is our line segment AB, find the coordinates of point P. So P, we're just going to kind of write in approximately, such that the ratio of AP, so it'll be A to the point P to PB, so it'll be point P to the point B, is 1 to 3. And then plot the point P. So we first have to find the coordinates of point P and then plot it. So let's go ahead and just take an educated guess that, let me see if I can put a point in here. Oh, I can put a dot. So let's just take an educated guess that point P is going to be around here somewhere. Because approximately it's going to be a ratio of 1 to 3. So if we were to divide this into basically 4 equal parts, it would be 1, well, that actually isn't very good. Let's see if I can move that a bit. So it'll be 1, and then let me do another dot. Didn't mean to do that. 1, 2. Okay, so this is terribly rough. 3. Okay, so this obviously isn't working very well. So if we do that, so we've basically divided this into 4 equal parts. And this is just a guesstimate at this point, so it's 1, 2, 3, 4. And so that way we could guesstimate that P is going to be right here. So let's go ahead and delete these ones, which I just put in to visualize, and there's all these extra points all over the place. And then let's go ahead and just label this as point P. So that's going to be point P. All right. So then, so the first thing is to basically, we have a ratio 1 to 3. So the first step, let me just go step 1. So add 1 plus 3. And so then we're going to get 4. So that's basically our whole. So the whole thing is going to be 4. So then step 2, okay, let me just do another thing right here. There you go. Okay, step 2, find the coordinates, find the coordinates of points A and B. So let's just go ahead and write those in here. So point A is basically, the x-coordinate is 1 to negative 1, negative 2, negative 3, negative 4, negative 5. So that is negative 5. And then the y-coordinate, of course my box right here is in the way, but it's actually negative 1. So if we look at it now, then the y-coordinate is negative 1. And then the coordinates of point B are 1, here we go, 1, 2, 3, 4, 5, 6, 7. 7, and then the y-coordinate is 1, 2, 3, 4, 5, 6, 7. So it's basically 7, 7. All right. Okay, so then to find, let's go step 3, to find the horizontal component of, actually let's do this, to find the x coordinate of point P. So we're going to use this number that we got in step 1, 4. And so we're going to find 1/4. So remember that point P is 1/4 of the length over from between A and B. So we're going to go 1/4 of, and then of the horizontal component. So let me just write that in. So horizontal component, and then we're going to add that to x sub 1. So let's go ahead and do that. So we know the horizontal component. If we just use it on the graph here, the horizontal component is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then we can go 1/4 of 12, and then plus x sub 1. And so x sub 1 is -5. And so then 1/4 of 12 we know is 3. 3, and then -5 over here, -5, and so then that is equal to -2. This is -2. Whoops. So now we know that the x-coordinate of P is -2. So let's just leave a space to put in the y. So let me just go ahead and move this whole thing up so that there's room for us to do the y component. So that's step 1, step 2, step 3. So then let's do step 4, and that's find the y coordinate of point P. And so then similarly to when we found the x component, we're going to use the same ratio 1:4 because P again is approximately 1/4 of the distance between A and B. So it'll be 1/4 times, and then this time it's going to be the vertical component, and then plus, and then y sub 1. So y sub 1. And so then 1/4 of the vertical component. So we know the vertical component is going to be, if we start here, if you draw in your triangle, it's 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8, and then plus the x1, which is -1. And then we know that 1/4 of 8 is 2, then -1, and that's equal to 1. So then we can go ahead and put in the y coordinate here. And then now we can go ahead and just move this appropriately. This is -2, right? So we can move this to -2, 1. So -2 is there and 1 is there. And so then that is basically how we find point P, so that AP to PB, so let's just go ahead and write the n right at the end. So now we know that AP to PB is equal to 1 to 3. Alright, so then take a minute to think about that, and then go ahead and finish examples 7 and 8. Let me see if I can find that. I always have trouble turning this down, turning this off. Let's see if I can do it. It's supposed to be right there somewhere. No? Alright. So let me go ahead and close that out. And then let's see if I can quit. I don't want to force quit. No, Finder, QuickTime Player, cancel. Alright, whatever. Let's see. There has to be a way to quit this. Do you want to save the changes? Save. I actually didn't want to do that. What I want to do is stop recording. It's not this one, I know. Actually, escape. Crikey, is it that right there? Oh, there it is. Nope, it's not that one.